A cuboid is a six-sided figure with at least two opposite sides taking a rectangular shape. So we have this diagram here. It represents a cuboid. The length from here to here is what we call the length, or the distance from here to here is what we call the length. And then the distance from here to here is what we call the width or the breadth. And then the distance from here to here is what we call the height. Now for us to get the surface area of a cuboid, we need to get the areas of these sides and we sum them up. And the formula we use depends on whether the cuboid is closed, open on one side, or open on both sides. So in case it is closed, then we say the surface area is equal to 2 into length times width plus 2 into length times height plus 2 into width times height. What we are calling length and width is this one times this, and that will give you the area of the bottom and the top because they are equal. And this one, length times height, will give you the area of this rectangle here. So we have this one having measurement length and height being the front side and the back side. And then width times height is this side or this face, which has this as the measurement and this one. So the one which is on the right side and the one which is on the left side. This is a situation whereby the cuboid is closed, meaning all the sides or all the faces are present. But in case it's open on one side, meaning one part of these rectangular sides is missing, and in most cases we take the top, then the formula to use is length times width plus 2 into length times height plus 2 into width times height. You can see this one does not have a 2 because the partner, which is the top, is missing. So the area we are going to look for is the bottom part which will take this formula to find its area. In case it is open on both sides, in this case we assume that the top lid and the bottom side on which the cuboid rests are missing, then the formula to use is this one, 2 into length times height, and then plus 2 into width times height. So this is a situation whereby the bottom side and the top side are missing. We have an example to drive the point home. We have been given this cuboid measuring 50 centimeters by 40 centimeters by 30 centimeters. So the length is 50 centimeters, the width is 40 centimeters, and the height is 30 centimeters. We have to calculate the surface area of the cuboid given that Roman 1, it's closed, Roman 2, it's open at the top, and Roman 3, it's open on both sides. So starting with the first one, if it's closed, then it means we shall use this formula here because all faces are present. So we shall say that's the figure I've just duplicated here. And then because we want to calculate the area when it's closed, we shall take the formula. That's the first formula, which says surface area is equal to 2 into length times width plus 2 into length times height plus 2 into width times height. So that's equal to 2 into our length is the distance from here to here. So we shall have 50 times the width is the distance from here to here. So times 40. Then plus 2 into the length is still 50 from here to here times the height, the distance from here to here, which is the same as the distance from here to here, and it's 30. So times 30. Then plus 2 into width. This is the width, 40. Then times the height, which is 30. The next thing to do is to simplify what we have here. So 50 times 40 gives us 2000. So we shall have this as 2 into 2000 plus 2 into 50 times 30 gives us 1500 plus 2 into 40 times 30 gives us 1200. Then multiply this and this, you get 4000 plus this times this gives us 3000. Then this times this giving us 2400. You sum these ones, you will get 9400 square centimeters. Now we come to the next question, where we are assuming that the cuboid is open on or at the top. So we shall use the formula when the cuboid is open on one side, this one here. So we shall say surface area is equal to what we had as the formula. And then that is equal to length is 50, the distance from here to here, times the width is 40. So 50 times 40, then plus 2 into length times height. The length is 50 times the height is 30. So 50 times 30, then plus 2 into width. The width is this distance from here to here, which is 40, times the height, which is 30. Then we simplify that. The first one will give us 2000 plus this gives us 2 into 1500 plus 2 into 1200. And if we simplify that, that will be equal to 2000 plus 3000 plus 2400. And that gives us 7400 square centimeters. The third instance, or the third question, is when it's open on both sides. In that case, we shall use the third formula, where the top and the bottom sides are missing. In that case, the formula will be the one that we have up there, just duplicated it here. That's equal to 2 into the length is 50 centimeters. So into 50 times the height. The height is 30 centimeters. Then plus 2 into width is 40 times the height, which is 30. Simplify this, that will be 2 into 1500 plus 2 into 1200. And that simplifies to 3000 plus 2400, which gives you a sum of 5400 square centimeters. Now, I want to point out something here, that when we are calculating the surface area of a cuboid, if it's open on one side, then you must be keen to note which side is open. It's not always the case that the top side is the one that is always open. Sometimes you may be given a question which definitely shows that the side that is missing is not the top one. Like for example, a nest. You may have a nest where this one is missing, this one is missing. Another example of a situation whereby it could be open on a side which is not the top one would be if you are given a garage which takes the form of a cuboid. If this is a garage or a parking yard, then we obviously know a car comes in through this point, or maybe from here. It can't come into the garage from the top. So in that case, chances are that what will be open will be either this side or this one here. Then if you have been given a question that involves the cuboid being open on both sides, sometimes it can be that the sides which are missing are not the top and the base, but it could be these two sides, maybe this side and the other one on the left, or the front one and the one which is at the back. For example, if you have a culvert which takes the form of a cuboid, then we know a culvert has two opposite sides missing, and in that case it cannot be the top and the bottom. Rather, it could be maybe this left side, this right side and the left one, or the front one and the back one. So in our next lesson, we shall have an example of how to calculate a question that involves a culvert. Thank you.